Hello and welcome to our online webinar. My name is Holger Kast. I'm the Global Training Education Manager at Tree Dental Implants. I am a dental technician and also I did work many years in the developing at Straumann, and this is where I met the first time Vanik Kaufmann, a master dental technician, and we did develop in these times already a lot of CAD/CAM and virtual planning softwares together, and I'm really happy to have him as our speaker for our interesting topic today: 3D printing, advantages, possibilities and limits for a best practice digital workflow. But before I'm going to give the word to Vanik, I would like to introduce you in our 3+ digital workflow sheet. So basically, it's important to do the digital prosthetics. You need to have a scanner, or you need to use a scanning data, and for this we are an open system, so we work with the leading companies in CAD/CAM and guided surgery. So as you can see on the left side here, you can use an intraoral scanner or an extraoral scanner, a model scanner, or you use a CBCT scan to virtualize the mouth situation or the model situation. We offer guided surgery products like our guided surgery sleeves to do a guided surgery for the implant placement. Therefore, you need implant level scan bodies, for example, and also it's possible to use an abutment scan body, and you need different abutments which you are virtualizing for digitalizing them into the computer. And there I'm very proud to show you the first time today our new products, or give you a small overview for our new products which we're going to launch in 1 week at the AAO in Madrid. So all these new products we're going to launch there. We're going to have a scan body for abutment level for our multi-unit line. We're going to have a 3D digital analog, which Vanik is going to talk about with 3D printing models. And then we have new bonding bases for the multi-unit line on abutment level. We're going to have milling cylinders for non-engaging and engaging solutions. And this makes me really proud to introduce you very quickly in a very new and unique in the market, unique bonding base, cementable bonding base. We call it the tree base. And actually the tree base, we have a patent on it because it's the first bonding base in the market which allows you to do out of one shape. As you can see here in the middle, you can do 4 different designs, so individualizing this abutment to your mouth situation, to the anatomic situation of the patient. You can actually, you see these lines, here's a horizontal line and here's an angulated line, and so you can either, the dental technician and also virtually in the software, you can cut this abutment in 4 different designs. So first one would be just this shape as you have it, as normal bonding bases in the market from several different companies are. You can have it like this, but you also, with our new patented bonding base, you are able to cut it, for example, here on the horizontal line to this design, or you use the angulated line to cut it to that design. And if you combine the angulated line and the horizontal line, you have this design on the right side here on my slide. And so it's the first bonding base in the market which can do 4 different And so if you want to know more about all these new products we're going to launch, please visit us at the ARO next week, I think the 7th and the 8th of October in Madrid. And now I'm really happy to give the word to Vanik Kaufmann. Please go ahead, Vanik, and introduce yourself, and please go ahead. Yes. Hello, Vanik.
Okay, hi guys, you hear me? And
I think so, yes.
okay, let's get started. Okay, my first name is Vanik, and I'm a lab owner in Switzerland. We have about 15 people, technicians working for us in our lab, and we do all kind of techniques. I'm also an instructor for different dental companies, developed the software, the in-lab for Sirona. I was a teacher at Greifswald University for dentists who want to have their master degree in CAD/CAM dentistry and digital dentistry. And so there are many things which I've been doing. But the last 2 years have been very, very, very interesting for me because I've devoted all my time to 3D printing. And showing you, 2 years in about 40 minutes is not so easy. So I'll have to rush through this presentation a little bit. So we'll go over time a little bit. 3D printing has become a big topic. And I think this is the future in dentistry, in dental offices and also in dental labs. Because you don't waste material and you have every type of possibility, especially with all the intraoral scanners nowadays coming. Like, I want to first show you how hard it was for me, getting started in this whole thing with 3D printing. Okay, so when I started 3D printing, it was really difficult. The way was very rocky. There were lots of traps and holes and problems to overcome. So that was the start. Then I had to get lots of answers. What does 3D printing mean? What are we talking about? And people tell you all kind of stories. And because we didn't have so much knowledge, I had to believe everything. And then finding solutions, especially in the dental field, because 3D printing is one side in the industry, but dental is a whole other side. Finding ways to print models and all type of models. And then utilizing the 3D printer for the dental field. So I want to talk about all these issues in this presentation. So about 2 years ago, I decided to build my own printer. I said, I want to know more about this technology. So basically, I built a printer, and you see in here in the printer there is a projector, an ASA projector like you see here, and this projector projects light up here with your image, and this thing goes up and down, and basically prints. So this was the start. But like everything you start, you get objects, and the objects look good, but the fit was not so good, and it was also in the beginning not so easy. I had lots of situations where models were not fitting, and it was a disaster. So this is all bad quality work. So then I decided, okay, I gave it a try. Let me go for some industrial printers. Look, something which I can use in the dental field. So I was looking around, what is around on the market? And you have huge machines like you see on the left-hand, object machines and everything. I said, this is not interesting for me. Then I was looking at the Formlabs type machines. I said, this is not interesting because we want something really for the field, for the dental field, something also in the accuracy. Then the Bego machines, all these machines, they were not really the answer. The reason why I don't want big machines is because when I print objects, then I'm blocked the whole time. I would prefer to have 4 or 5 small machines and distribute the work on those 4 or 5 small machines instead of buying one expensive machine. This way we are more flexible. So then the decision was build your own printer, find a partner, and that was the idea. I found a partner and we started building our own printer. And the idea of this Vitro 100, this is the first printer only made for dental purpose, okay? So for dental office, for the dentist, he can print all his temporaries, and there's so many things he can print. The dental laboratory, naturally all the models. And compared to many of the companies nowadays, companies like Straumann and all of them are jumping on the 3D printing market. The problem is these companies are so huge. They buy big companies and then they think they can convert the industrial printer to a dental. We did the opposite. We started from scratch for the dental market. And that's one of the reasons why the printer is so successful and works fantastic. So the thing is, what do we want to print? And just a few things which I want to show you here. One of the big things nowadays are aligners. Okay, Invisalign, we all know the patents have run out. So how does that work? Basically, you print your models and you thermoform your foil over it. Many dentists think that the Invisalign foils are milled. This is not the truth. The truth is they're always thermoformed over a modified model for each step. I will talk about this a little later on. Then temporaries. This is something which is fantastic when you do 3D printing. We have shades A1, A2, A3. So the dentist, if he does an intraoral scan, he basically designs his temporary bridge and prints it. It takes about 15 to 18 minutes to print a 3-unit bridge, a single crown, or 10, 14-unit bridges. So the time doesn't matter because it's the height of the object you print. And the quality which we get with materials, we are using material, a twin smile material, which is really fantastic. We get beautiful shades, they look good in the mouth, and we can make also very nice mock-ups. So we have lots of possibilities. We think the next step will be also, we'll be printing in future temporary dentures. We are thinking even to start printing dentures as like a 6 to 8 month solution. Like when you throw your lenses away, monthly lenses, why not have like a yearly denture? We get every year you get a new denture. And relining is no problem because you scan the impression and just reline it digitally. Then naturally printing models, that's become a standard. Implant drilling guides like you see here. We use these implant drilling guides basically as positioning guides. I will talk about that later on. Lots of Michigan splints we do nowadays, extremely. Naturally, if you do these kind of things, you can also print your chrome partial and then cast it, or print your bridges. Instead of milling them out of wax, you can cast them. So we have all kinds of possibilities. Here you can hardly see it, but these are called testineers. These are like mock-ups which we make from Twin Smile, and they really look fantastic for checking your smile. Custom impression tray is another area which we do. And so let's go into the presentation and have a look at a few things. So, usually this is like one load which you just printed, models for aligners, impression trays, something to be casted. And when we print, we always print a small cubic like you see here. It's a 5mm cubic, which, especially when we get digital data, because we don't know how, we have nothing to compare afterwards. So we print this and check with every print, did our printer print right? So we need 5mm and we get 5mm. So let's start with aligners. Aligners nowadays is a very, very profitable business. And every dentist can do this because it's not a thing for the orthodontist. Sure, from Twin Smile we offer our own aligners, but you can do your own. You can also get the planning for us. But if you decide to do your own in a dental office or in the laboratory, basically get the right software. The software we use is called Maestro 3D. It's a company from Italy, and they make a very, very good software. So we basically correct the position of the teeth. The software tells us how many steps we need, basically, and then the computer will give us a very nice report, before and afterwards situation like you see here. And basically in 9 weeks we do our frontodontics. We call this frontodontics. We do this in about 9 weeks. And so it's very, very economical, and the profit stays in your pocket, so you don't have to give it to anybody else. So you print your models. It depends if it says 3 models, 4 models, 5, 6 models. You print them, and you use from a company called Shoei. You use their foils like you see here, and you basically manufacture with the thermoforming these products. So we manufacture these aligners. We have a very nice box with the model, and the patient gets those. This is our Twin Smile Center in Switzerland that you see here. So we have a small education center where we train patients, dentists, and technicians. So be profitable in your lab and in your practice with aligners. This is a whole new thing. Then something else. Many dental labs have to make custom impression trays. Also dentists. Now, I said, if you have to make the custom trays, why don't try to make it yourself? Why, as a dentist, you have to send it to your dental lab? And as a lab, why do you need to have precious technicians making these trays? Why don't you basically design them? And so we developed a software with Sirona, and the software, it was all done in our laboratory. It takes you about a minute and a half, maximum 2 minutes, to design the perfect impression tray and basically print it. So basically, you have your data. It's either a scan or a model which you scanned, and then you basically put the insertion axis. The software blocks out all the undercuts, and you just draw one line around the model like you would do it with a pencil, and then you automatically get the recommended tray. You say how thick you want the tray. You can do anything from 1 millimeter to I think about 4 millimeters. So, and you say how much space you want for the impression material in between. Naturally, you can add stops if you want. You can add holes. You can do whatever you want. Once you've decided that, basically you go to the next step, and the software will ask you, do you want implants? And you say, yes, I need to have these chimneys like you see here. And these chimneys can be put in any direction. So you can tilt them, you can move them, and then you add also the grip if you want to put the grip. You can put also side grips. Whatever you have learned, you can do. You can put holes into your tray, and you see we have a very nice guided tray for our custom impression afterwards, which we very often don't get when we try to take a plastic tray and just make a hole into it. Then we print these trays in the Vitro 100, and we have been printing them with this orange material. Nowadays, we have gone to a transparent material. We think the transparent material looks even nicer for the trays. We position the trays. You can position them either standing, you can position them layering, so you can do whichever way you want. And we can print up to about 5 to 6 trays. It depends on the size of the trays in one shot. So once the trays come out, you basically break off the supports, you clean it, and basically you can send it to the dentist, or you're in a dental office, you can just start making your impression. The next thing, we do lots of Michigan splints, like you see in this situation now. Either we get the intraoral scan, and we get scans from Carestream, we get scans from Sirona, Tree Shape, and on and on. But the software we use, which we really like very much, is the software from Exocad. And so we design the splints. The first thing you do is you block out all the undercuts like you see here. You design your splint like here. You make the canine guidance somewhere here, and you virtually grind in the occlusion. Then you have a virtual splint like you see here. You place it. We place it this way so we don't destroy the occlusion which has been grinded in. And basically we have now our tray printed. And I just want to show you on the small video here. I sent it to a friend of mine, Boris, in Russia. And this has come out of the print, and we just put it on the model. So I just would want to show you, how this worked.
Hi, Boris. We took it off the printer, and we put it on the model now. See if it's fitting. Fit is perfect. No adjustments, nothing. It just fits. No moving around, nothing. And now we put this in the curing machine and cure it like this and make it completely hard. That's all we do.
Okay, so you see, this is what we like. There is no that you have to fit it or bother or something. Basically, it always fits. You can also adjust the undercuts, so you can say, I want it fitting tighter, I want it fitting looser. We all don't have this when we try to mill it. So here we're using a material from Datax, which has been proven excellent, or from Shoei even. And sure, you can make all kind of trays, different variations, and print lots of them. Something new which has become very, very popular, which we have started, is positioning jigs for brackets. We design the position of the brackets. It depends on the type of the brackets. We have a special order form, and we make this kind of window like you see here. So we print these things, and you see this little window, so the bracket will just push in perfectly. So this jig, once you bonded the brackets, you can always go off and on. You don't have a bracket which you fill with composite, and the composite gets squeezed into the interproximals like most of the silicon brackets. So here, it takes you about 5 minutes to seat these brackets in the perfect position. So basically, you put this thing in the mouth here, you put your composite on the bracket, you place the bracket, you cure it like you see here, and basically you have no waste around the teeth of your material. A very, very fast way, very helpful way for doing this. There's now a new material coming out, which you can see here on the right-hand side. It's even a flexible material. So I've tried to bend it here on the left. So this material you can press and is flexible for positioning brackets. So this is really, really interesting that we can do these kind of things. What materials should be used for 3D printing? What kind of liquids? First of all, I recommend the liquids which we are using now, because the ones we are using have been really working excellent. We are using from two companies. One is from a company called Datax out of Germany, close to Karlsruhe. Excellent liquid. And the other one, which is also excellent, is from a company called Scheu in Germany. So these two companies make excellent liquids, and they work in the 385 nanometer light range. So they are just in this area, in the ultraviolet, before it becomes visible light. This is very important, because this is the only wavelength in the highest possible length which the liquids will not discolor. Any other liquids nowadays, if you have a Formlabs printer, you usually see that the liquids become a little bit yellowish or bluish or whatever. They will discolor with the light. So we don't want our things to discolor. We don't want our temporaries to discolor. That's why we use this. I don't use the Nextent liquids or those kind of liquids, because I don't want to use a liquid like in the 4 or 5 nanometer range which will discolor. And something interesting, these liquids we have here are very thick. That means you can hardly smell them. Other liquids, like you see here, the whole room smells. So you have a lot of free monomers floating in your room, and I don't think that's very good for your health. So personally, I would recommend some of these German liquids, which really seem to be also not an issue on the health situation like some other companies. So we can print models with removable dies. We can print models for dentures, models for retainers. We do a lot of these impressions we get here, and we manufacture retainers still by hand. Lots of dentists ask us for this, so we get an impression. Try to make an impression with your alginate, but you can still see the wire like here. This is not possible. It always tears the alginate. But with 3D printed models, very nice. We print the name of the patient on the model, and basically the dentist gets this model with the retainer. Naturally, we print a lot of these things here, like you see here, for placing your implants. We don't call it an implant, drilling or how you can say, positioning guide. It is basically that the dentist knows where we would like to have the implant positioned. So we set up the teeth, and then we print where the teeth were the holes. And so if the dentist now is free, he can take a pilot burr, make a small hole, and he knows where we want to have the implant. He decides what kind of angulation he needs because of the bone situation. And especially, with tree implants, we use a lot of tree implants. We think they're excellent quality, the tree implant, and we have been very successful with the tree implants. So they have very nice, angulated parts, especially with the new bonding bases which they have. We have very good results. And so if the dentist puts it in the right position, but if it's a little bit crooked, it doesn't matter. We can correct all these issues in the dental lab. So now how does it work? So when you print your models, basically the models stick to a tray like you see here. So you have to take something like this and just swap them off the tray. So you just move them off the tray, put them in alcohol like you see here, isopropanol alcohol, and then you clean it for about 4 minutes in the ultrasonic. After that, we put it back in a light curing oven. Nowadays, we are using a different type of oven from a company like NK, it's called Otto Flash, which has got also nitrogen. With nitrogen, we get a better and a harder surface on our things. After printing, usually we put the liquid back to a strainer, like you see, and put it back in the bottle, because we don't want any floating parts in our liquid, because liquid is kind of precious. We've figured out that a printed model works out to about €8. So this way, we put it back, and we put it back into the thing here. Okay. The next thing is, people get problems like you see here. This is when we started. We're getting misprints, things falling off, and all this time, and everybody blames the printers and all those things. It's basically your fault, or it's the software of the printers. That is one of the biggest problems. None of the printers which I know in the dental field have a good software. They all have really a problem with their software, because most of the cases which we get, it's like Swiss cheese. The data has got holes inside it. If you have holes in your data, you need something to fix those holes. Otherwise, you'll get misprints, okay? So that's why in our software which we have, the Vitro software, the moment you import basically your model into the printer software, it has a repair function. It fixes all holes like you see here, okay? It generates supports if you need supports. Then something very important, our software can also make the model hollow, so you don't have to export it to a system, do it hollow and re-import it. You do this all in the printing job. We also can write any type of name, anything you want on the model. This is a big, big thing. We can make holes into our model, because when you print a model which is hollow and you print it on the base, you get like a vacuum during the printing, so we make small holes. So all this has to be done during the printing, during the software before you start printing. And 90% of the software in the dental field don't have this ability. That's why I said this is the most important thing for us. Putting the text on it, putting the supports on it, placing it that we can have as many models as we want, cutting it. Let's say you've put it on the model and you realize, oh, I don't need this area. You can cut this area away like you see here, okay? So we can do any cut function before we start printing. This is a big, big advantage. Here, just to show you, we print 1, 2, 3, 4, 5, 6 models, okay? And you have to imagine, before it prints, it has to slice this model. It's like a cucumber. These models get sliced in pieces. So it decides, you have to decide, what do I want? 100 microns, 50 microns slices. And when you do that, then it cuts slices 50 or 100 or 25 microns up the whole model, like a cucumber. And it makes images of these slices. So you see all these slices look like this. So the more slices, that means the finer you have cut your model. So if you have, let's say, 25 micron slice, you have very fine slices like you see here. You have 50 micron, you have little rougher slices, 100 micron, you have bigger slices. Now, this has nothing to do with the accuracy. This has only to do with the optics. So basically 100 microns is good enough. If you go for 25 microns, it looks better. It just takes you longer to print. Now, when we have these slices, you have to imagine, you can examine these slices. Sometimes you will see, especially on this slice here, you see there's a mistake here. I hope you can see this. It's this one. There's a little bit missing here. So that means this model was not completely flat. So it'll misprint the first thing here. We can see it on our software. Okay, we can check this. And if you have a situation like this, basically, it's only the first 2 slices which you would see something like this. That's why you only check the first and the second slide. The others, you don't worry. You basically repair it, okay? That means if you look at this here, this model which is not accurate, this was the 3rd model here, compared to this model, you don't see a difference. It's flat, but it's a little bit darker, so a little bit is not touching the base, and because of that, you will get a misprint. So we have to tell the software, correct it and adjust it to the right position, and then we will get very, very nice prints. Now, you know, what kind of software what kind of a printer shall I buy? The problem is we have SLA printer, this is a laser printer, or we have DLP, digital light processing. I'll just explain this in a few seconds. I recommend not to go to SLA printers anymore. These are excellent for home use. You know, if you want to make a prototype model, but we want to do rapid manufacturing. Okay, we need to work on these models. We don't need to have a model which is prototype where the systems like you see on here, the accuracy is okay, but it's not like for the daily use. And the time here, they are so slow. Okay, so basically, how does it work? The SLA printers, both of them, there's a light source from underneath. Light shows up here. In here, we have the liquid bath, and the light cures layer by layer. So the tray comes down, it cures, it goes up. The laser basically is also light, and the laser basically cures layer by layer down here. Okay. And if we look at it, it looks like this. The laser, because it has to go layer by layer, takes very long, and the DLP, it gives you the whole image in one shot. Okay. You can see this is one image. The laser is still making the same picture like here. It's going left and right. The first images are already done here on the right-hand side. And then it goes to the next image, to the next image. The laser is still working on its first image, okay? So that's why the lasers are very, very slow. and the accuracy is not so good because the point of the laser is 140 microns. On most of them, like on the Formlabs, it's 140. So XY accuracy, I don't think we will get better than 150 microns. Okay, that's why it's for prototyping, these are good. For manufacturing, these are good. For your idea, it takes us to manufacture 3 impression trays, custom impression trays, in about 40 minutes. In an SLA printer, it takes about 3 hours or 4 hours to produce them. So they're very, very slow. And that's why it's not feasible. But if you want to get started, it's very inexpensive. You can't do anything wrong with something like this. But for the next step, you have to decide on something that you can do your daily work. Now, be very careful when people talk about, they say, oh, we can put in 25 microns, we can put in 50 microns. What they mean are the Z layers, the layers which are like this. But what is important is the XY, the volume of the form of your model. That has to be from 100 microns lower. And we think 100 microns is good enough in the dental field. 150, 140 is too high. Some people say we print at 97, some say at 80. There is no difference. You will not even realize anything. So 50, yes, maybe, but it's not really very important printing at 50 microns. So 100 microns is what we are looking for. So the way it works, the light from underneath cures your layer. So let me see if I can try to show you how this works. Okay. You see here 100 microns, okay. This will be the position of our object here. If you say I want 50 microns, basically, what happens is you have to move the position of the projector closer. When you do that, that means your build object will be smaller. That's why you see some companies only small, very small build areas, because the projector distance is very close to the vat which they have here, to the liquid, and so they can print at 50 microns, but it's not really usable in the field because you can only print the size of a model with 50 microns. So we think 100 microns, and we can utilize nearly the full build surface, and we have not been seeing any difference. Okay, so that's why we print with 100 microns or something with 70 microns. That has no issue. So what can we print? We print jigs like you see here for checking the implants, if the implants are fitting like you see here. If it would not fit, the dentist could cut this, fix them out, and make a new impression over it. So in this situation, we printed also the impression tray with stops in the impression tray, and with also like screw hole placement devices. So you basically have the impression the screw holes are not filled. But luckily, we didn't need this this jig because the fit was perfect. He checked it, there was no bouncing, and it fitted perfect. Then something else also we have developed, I have a patent on this, implant analog for 3D models. And many companies will be coming out with this 3D analogs. What we have done, we have taken the most easiest way. We said we need an analog for 3D printing with a flat surface, with a stop here. And we also want to be able to use it on conventional models. So you can use the same analog on a conventional model. You have then the retention here. On a 3D model, you have here an area where it's a snapper. So it snaps in this area. And the nice thing is you only have one part. Many companies nowadays are trying to come out with two-part solutions, and believe me, if you have a two-part solution, you try to screw this in here, it's going to pull down this whole part, and it's not really work. Some companies, they have a second sleeve, and on and on. This is the most inexpensive solution. I mean, we are talking a price around 10 euros for something like this. Okay. So how does it work? Basically, when you have the model and when you take it out, you will have this inside the model area where it snaps, and this is where the stop is. But like I said, many companies will be coming out, and it'll be interesting to see what's going to happen in the future. Because at the moment, these are just our situation here. Softwares like Exocad and Sirona will have this implemented in their software in the future. You print, you basically make a digital scan, you take this analog, you put it in here, and basically it snaps. At the moment, I'm looking now for a company who will manufacture these analogs for us. And in the US, we have a design patent on it. So if somebody tries to copy the shape of this, he'll have a problem. So this was basically to give you an idea, what's happening in the 3D field. We also make our testiniers like you see here. And these are mock-ups. and then usually after printing you cure it in a light oven like you see here. The thing is, in this short period, I was trying to give you a run through all the possibilities we have at the moment. We are at the moment in the stage where we are developing soft tissue for models where you want to have like also pink tissue on it. So when you do your implant designs, you have red tissue and color of the model. You can remove it, tissue soft. So that's very easy. It's working very good. We have a material for printing our denture bases that works excellent. So you print your denture bases. You basically print your 14 teeth and you bond it together with your denture base, and you have your finished denture instantly. The advantage of these dentures are that if something breaks, you don't even repair it and just print a new one, because the cost of printing is very, very low. We are looking at models like you see here. They are about 15 grams. So what we try to do is we try to print everything hollow. And this is also something which many of the companies nowadays who are developing software or models with their software, many of them don't have the option to hollow the models out. And that's a problem. That's why our software for our printer has this function. But if you're using some other company's software, be sure that they in future make the software to hollow out the model before you print it, because anything solid makes everything expensive. Something else also, if you're making models which are hollow inside and you want to thermoform something over it, you have to be careful, because what happens is the models implode into themselves. So if we know we're going to thermoform something, we just pour a little bit plaster back into the model, not to make it implode, because we want to keep these models as light as possible. Okay, and the thing is, the message which I want to give you to all of you is, be careful what you hear. Everybody tries to sell you something, and also be very aware of the after cost. I didn't go in details like in our printer, we don't change the tray, we just put a new foil into it. All these little things are adding up, and that's why, or when you get a skin from somebody, that means the skin is like a 3D intraoral scan. That skin is not a solid scan. How do you make it solid? Do you have a software to make it solid? How long does it take you to make it solid? These are all answers. That's why the course which I teach in one day, it saves the people about 2 years of learning what I had to go through. End of the day, the quality counts. We have to manufacture good quality, and we have to find the balance between doing it fast and doing it cheap. And we also have to find a way to survive, because through all these new materials, the cost, the price of our crowns, of our work which you do is coming down, and we have to be profitable. So I think I am done, and I am ready for taking some questions. Holger, thank you.
Yeah, thank you very much for this nice presentation. 1 second, and I have to get back to my presentation. Thank you very much, Vanik. We have now the possibility to ask questions to Vanik Kaufmann. Please write your questions in this question field on your tool button on the right side. You see a question field. Please write your questions, and I'm going to give them to Vanik. And I have already the first question. Do you expect major development in the future, or is it a good time now to invest into a 3D printer?
That's a very good question. The thing is, it's like buying 3D milling machines. When is the right time to buy a 3D milling machine? So there will be developments. We will see other materials in the PMMA side. That's what I've been showing you here. I think the start has done, and it saves us a lots of time. We will be seeing in future that we will be printing materials out of filled materials like composite. We've been working also on a 3D zircon oxide printer. We have a prototype running. But that's a different story on that type material. The advantage printing zircon oxide in its green stage, you can do multi-layers of material. So I think the time now is right, but you have to invest time in learning the technology. If you just buy a printer, it's going to be a disaster, because all the steps in between, the cleaning process, the placing of it, all that, in the dental field is different than any other field. I had to learn that all myself.
Yeah, okay. Then there's a question from Dr. Jörg Siever. What's the price of the Vitro 100?
I think the price is selling for around 14,000 euros, in that range, what I've been hearing. And there's no extra, dongle fee or whatever, and all that on and on. So basically, you use whatever liquids you want.
Okay, then there's another question from Dr. Giulio in Italy. What about metal, titanium, ceramic, 3D printing? Is it possible to use print these materials?
Yes, it is possible, and in our research lab with our partners, there is a zircon oxide printer, like I said. There is also a bone printer for printing like bones, artificial bone, and they have a metal printer. The metal printer is very exciting because there's a huge company behind it. The company is called Instec, and they manufacture printers for printing Tesla parts, Boeing parts, and all that. And I've been working very close together with them to have maybe a small one, a desktop printer for our metals in future. It's a system which doesn't use any supports. It's a direct melting technology.
Okay, then we have a question from Colombia, from Dr. Perez. Can we use 3D printed crowns on the titanium bonding base directly as professionals, for example? Like, is it possible to print crowns on, for example, our new bonding base?
Yeah, it's no problem, because the data which you get when you design your crowns is an STL file. And the STL file we basically print. So that's what we have been doing. We have been printing on tie bases. Actually, we just did last week. I think it was a 12-unit bridge on, I think it was 6 tie bases. And the advantage was we can lift the bite with this material. Okay, we can correct the bite. We can do adjustments. And it takes about, like I said, depends on the height, between 15 and 30 minutes to do it. And you can print multiple of them. So yes, for provisionals, it's good. The materials have got class 2A, so you can use it in the mouth.
Okay, thank you. So then there's another question from Peter Kim. Do you think the future is setting up for the discontinued relationship between dentists and technicians with chairside scanner, milling, and 3D printers, etc.?
Yes, I think the future, because when I started 30 years ago, I was one of the fathers of the CEREC InLab, and everybody was laughing at us. 3D, milling, that'll never happen. What I can really say, I think single crowns and small bridges in the posterior region will completely disappear from the lab. I think even though I'm a lab owner, I'm a technician, we have to admit that it's going to go chairside. That is the future, and we can't stop this happening.
Okay. So far, I think this is enough question for now. If you have further questions, please write them or contact us on our homepage, which I show on our email address, which I show later on. And I would like to say thank you again, Vanik, for this nice presentation and really interesting topic, which for sure, it's my opinion too, it will be the future. 3D printing is coming, and we are ready for it with 3D dental implants as well. And I would like to take the chance shortly to give you an overview what is happening now with TRI dental implants. So as I already mentioned in the beginning, there is the EAO Congress in Madrid coming up from the 5th to the 7th of October, where you find us at the booth S16. to see our new innovative products which we develop, which we did develop the last year. And so please join us there at the booth S16. And really important is for me to announce the next online webinar is going to take place on the 15th of November with Ramon Gomez, Dr. Ramon Gomez from Spain. His topic is going to be 3 main considerations for successful immediate implants in the anterior area. So please take this 15th November in your calendar. It is going to be another important and interesting topic. And then there is at the end of the year almost, there's some master courses which I would like to inform about. And this is a master course from Dr. Mario Steigmann, Prosthetic Soft Tissue Development Model 3 from the 2nd to 3rd November. We have a few places still available. Please contact us if you are interested. And then there is a really interesting 3 days course, master course in the university in Zurich with also, from my point of view, a godfather of implantology, Professor Dr. Christoph Hemmerle and Professor Dr. Roland Jung are the main speakers in the 3-day course. And there's a lot of other dentists having a lot of topics about implantology. You get a really great knowledge in these 3 days. So please, if you are interested, contact us. And then the already 4th all on 3, which is more or less the all on 4 technique, all on 3 technique in our system, in the TRI system. We do the last part of our all on 3 course with Dr. Luis Beza from the 7th to 8th of December. There's also including a production visit in Zurich of our TRI production. And so please contact us if you are interested to be a part of these interesting courses. And then really nice to announce is the 3 World Congress, which takes place in Ibiza. The topic is also digital implants. So we're going to have really interesting speakers from the 4th until the 5th of May 2018. Please be a part of this interesting 2 days event. And then, as always, please get friend with us or like us on Facebook to be updated with all coming up courses, trainings, webinars, and so on. And at the end, I would like to thank you for participating on this webinar. Thank you again, Vanik, for this nice presentation. And if you have any further questions, then please contact us under academy@3-implants.swiss. So thank you very much and have a great day. Bye.
Bye-bye.